Have you ever pondered what makes the sun, that blazing orb in the sky, burn so brightly? What chemical reactions are at play within this celestial body that has fueled life on our planet for eons? Well, it's a fascinating tale of fusion, heat, and light. A tale that begins at the very core of the sun. Picture, if you will, an environment of extreme heat and pressure, far beyond anything we can replicate on Earth. It's in this furnace that hydrogen atoms, under immense pressure, come together to create helium in a process known as nuclear fusion. This isn't your everyday chemical reaction. It's a process that involves the very nuclei of atoms, the building blocks of matter. Now, every time two hydrogen atoms fuse together, a tiny bit of mass is lost. But don't be mistaken, it doesn't just disappear. According to Einstein's theory of relativity, this mass is converted into energy. And it's this energy that powers the sun, making it glow with the heat and light that reaches our planet. But what about the sun's surface, you might ask? Well, it's composed mostly of hydrogen, around 70%, with the rest being primarily helium. There are also trace amounts of heavier elements like oxygen, carbon, neon, and iron, but these make up less than 2% of the sun's composition. Although the sun appears to be a continuous, homogeneous ball of gas, it's actually divided into several layers. The core, where fusion happens, is the hottest and densest part. Surrounding the core is the radiative zone, where energy travels primarily in the form of electromagnetic radiation. Beyond that is the convective zone, where hot gas rises and cool gas sinks, transporting energy towards the sun's surface. Lastly, there's the photosphere, the visible surface of the sun, from which light escapes into space. So, to summarize, the sun's chemistry can be boiled down to a few key points. Firstly, the sun is primarily composed of hydrogen and helium, with trace amounts of heavier elements. Secondly, the sun gets its energy from the fusion of hydrogen atoms into helium in its core, a process that converts mass into energy, according to Einstein's theory of relativity. Thirdly, the sun is divided into several layers, each playing a crucial role in transporting the energy generated in the core to the surface and then into space. And finally, the light and heat we receive from the sun is the result of these processes occurring continuously for billions of years. So, the next time you feel the sun's warmth on your face, remember the immense, intricate processes taking place millions of miles away, fueling not just our star, but life as we know it.